Pointers we're going to look at is Chapter 7. So this will be the new content starting for the semester in 250. With pointers, once we start talking about pointers, we're going to use pointers for the rest of the semester. So this is an introduction, and you need to understand some basics here. The goal after this lecture, if you're looking in the book, Chapter 7, it's 7.1 is just a one-paragraph intro, and then we're going to cover 7.2 and 7.3. Okay, so that's only about 3 pages out of the book that we're covering today. The goal then is to be able to declare a pointer, initialize or assign a value, and then dereference the pointer and actually access that value. Okay, so it's very basic pointer operations. With that, you're going to have the lecture here. You're going to have the slide deck that I'll upload or have already uploaded. We'll look at a practice lab. We'll look at the code that we're going to use, and then we'll also have some practice, another like practice lab, practice code that you can work on as well. So we'll look at all that here at the end of the lecture. On top of that, there is the zip inside D2L that has all of the sample, all of the code from the book. Okay, so I highly encourage you to open that zip up, extract those programs, compile them, look at how they work, look at how they run. Okay, so plenty of opportunity to look at code here. All right, before we begin, then what I want to take a look at is variable refresher. And this isn't so much a refresher as it is I just want to discuss some things about variables that we never really point out in 150. And that is that when you declare a variable in the program, what the operating system is actually handing you is a memory address for you to store that value. Okay, we all probably knew that was happening. Obviously, that we need to store that value in somewhere, and we're not writing it to a file, we're not writing it to a database where it's going to be in memory. So the variable itself then gets assigned a memory address, and that's where we directly store that value. Look at this depiction here, you'll see that I'm going to use this blue box to represent some random or arbitrary location in memory. And then what this is trying to depict is that we've declared an integer variable. Excuse me. Make this look a little bit more like a C program. We declare an integer variable, we get some random location in memory, and we then can assign a value and store it directly in that memory location. So let's take a look at some code. All right, so here you can see I'm in the IA lab, and we're going to look at pointers intro.c. This is a file that I have uploaded in D2L under the code sample section, so you can follow along. And what I'm going to do is, as we work through this program, I'm just going to uncomment out things or decomment things as we go. So focus on the stuff that's not commented out right now. And I'm going to see if I can zoom this in just a little bit more. Font, maybe make the font a little bigger, use the system. Okay, so let's go to let's do a 14 point. All right, that's a little better. All right, so we declare one variable, it's an integer variable, and we assign it a value of 7. Okay, so integer 1 equals 7. If you look at the slide deck, that's the same thing that we were just talking about. Now up until this point, we've been able to use that integer variable in our programs, right? We can pass it as an argument to a function, a value to a function. We can multiply it, we can print it. Probably one of the first things we did was we simply learned how to print the value off. Okay, and that's what this line of code is doing right here. We're simply printing the value of integer 1. All right, this next part now is where we're going to start to get a little bit different. And we're going to print the memory address that was assigned to integer 1, the location in memory where it's storing its value. So in order to do that, we need two things. We need a different format specifier, that is %p, and then we need to use this address. It's called the address operator. We'll get into the address operator a little bit more here at the end of the lecture. But what you need to know is it's a unary operator that takes one operand. That means that it takes one argument. That argument is whatever variable you want to get the memory address from. Okay, so what we'll see when we run this program is we'll print the value of this variable, so we should see 7, and we'll see that it prints off the memory address. All right, so pointers intro.c, we'll compile it, we'll run it. Hold on one second here. Just make sure I don't have. All right, so for whatever reason that gave me. Okay, I must not have saved it. Let's try that again. Yeah, there we go. Okay, so obviously rookie mistake there. If you don't save the file and compile it, you're not going to get the version that you think you have. So save that file, recompile it, reran it, get the value of 7, and the output is, that's the memory address. I'm going to go ahead and bump up this, see if I can find it anyway. Font size here. I want this font size to be a little bit bigger. Let's see how that looks. All right, I think that helps. All right, so I'm going to clear it. I'm going to run it again. All right, so here you can see, here's the format when we look at a memory address. Okay, this is hexadecimal. Hexadecimal is base 16, so base 10 is what we normally use in everyday, day-to-day life. Base 2 would be binary, so 0 and 1. It's just the number of characters we have present in the numbering system. Hexadecimal is 0 through 9 plus A, B, C, D, E, F. Okay, so once we go past the number of unique numeric values, we go into the alphabet. That's why you see here different numeric or different alphabetic characters. We don't really have to care about that. Okay, the whole point is that when we start looking and comparing memory addresses, that you can see either this value is the same or different than another memory address. Okay, so that's really all we're looking at. Most hexadecimal values start with a 0 and an X, and that indicates that you're looking at a hexadecimal value, if it's not obvious because of the presence of these alphabetic characters. Okay, so let's go back to our slides. And now we can talk about pointers. So what is a pointer? A pointer is a variable. It's a variable just like any other variable that we declared, but the value is a memory address. A variable then that is not a pointer, just a normal variable, the variables that we've been using in 150, is a variable that directly contains a specific value. Okay, so we can say that a variable directly references a value and a pointer indirectly references a value. So let's look at the graphic at the bottom here. Okay, here we have integer 1. It has a memory address assigned to it, and it directly references a value. The value is 7. Now, let's say that we declare a pointer. We call that pointer variable count pointer. It gets assigned a memory address. We still have integer 1. It gets assigned its memory address. In integer 1, we have a value 7. And for our pointer, we assign it the memory address of integer 1. So now it can indirectly reference that value 7. Okay? That's why we need to know how to get the memory address of a variable, is because we're going to assign it to the value of our pointer. I'll probably say this enough that you'll get sick of hearing me say it, but the value of a pointer is a memory address. Okay? The value of a pointer is a memory address. So how do we define a pointer? We use the asterisk operator. Now, pay special attention to this asterisk operator because it has 2 different uses depending on the context in which we're using it. The very last thing we'll talk about today is the indirection operator. That is the asterisk operator. It's the dereferencing operator. The other way is how we're talking about it right now, and that is to declare a pointer. So how do we declare one? Well, we declare it just like a variable. We have to have a type that the pointer is going to point to. We have to give it a variable name. Variable name, just like same rules as defining any other variable. But then we add the asterisk operator in between the type and the variable name itself. Okay. We're going to use ints almost exclusively throughout this talk, throughout the lecture today, but that's just to be consistent. That's just to not provide any, try to eliminate any confusion. A pointer can point to any type. It can point to any primitive type. You can have it point to a float or a char or a double. It doesn't matter, but we're just going to use int. There's nothing special about that. It's just to try to keep things simple at this point. It also matches up with what the book does and how they introduce. So hopefully that just reinforces that point. You'll also see that in the name itself, I add the word, the suffix PTR, capital P, lowercase tr, and feel free to do that if you want. That's just a way to kind of reinforce to yourself that the variable that you're using later on in your program is a pointer, because once you've declared it, you don't know anywhere else in the program that it is in fact a pointer, okay, without going back and looking at the declaration. So this is just to help if you're not familiar with pointers, if you haven't used them before, you're just not overall that comfortable, just a recommendation in order to help keep straight in your mind what kind of variable that you're working with. Let's see. So we'll take a look at this, the asterisk operator. So oftentimes I'll see in code that when people want to have multiple variables of the same type, so let's say that we want to declare multiple variables of an integer type, you'll do it all in one line, and that's fine. You'll do int and then the names of the variables separated by commas. One thing you have to keep in mind with a pointer is that asterisk operator only applies to one variable at a time. Okay, and we'll take a look at that here in just a second. All right, so as we go, I'm going to try to comment some of this code out so that we don't get too much output going and clutter up what we're trying to talk about. I'm also going to keep this stuff below commented out. All right, so line 15 here. This is the easiest way. This is how we declare pointers. Okay, here's the type, here's the name, and then we have that asterisk operator. Now, that asterisk operator can go anywhere. Okay, this is how you're typically going to see it. You're going to see it right in front of the variable name. But if I did this, it's the same thing, and if I do this, it's the same thing. Okay, it doesn't matter. Either way, this declaring first pointer as a pointer to an integer value. Okay, I'm going to try to stay consistent. You will see here towards the end of the semester the book starts to jump around a little bit. If you look at samples online, you'll see that people will argue why they want it in one position rather than the other. I don't care as long as you know how to declare it a pointer. All right, I said pointers can point to anything. So if we say float pointer, okay, now that's a pointer that's going to point to a float value. Right? We're just going to stick with int just to keep things simple. All right, finally, here is declaring multiple pointers on one line. And what you have in this line is you have one pointer, which is int pointer, and one integer value. Okay, so keep in mind this asterisk operator, when we're declaring a pointer, it only applies to one of them at a time. All right, now that we know how to declare them, we also have to take great care in initializing the value. There'll be three ways overall that we talk about initializing a value. We can use 0, we can use null, or we can use a memory address. First, we're going to focus on 0 or null. And as far as I'm concerned, you can use the two interchangeably. Null is going to give you the same result as 0. Why do we do this? Well, in 150, you should have talked about that when you declare a variable, we now know that that variable gets assigned a memory address. If you use that variable, and it pulls out whatever is in that memory location, it may or may not make sense. If you haven't assigned it a value that you want in your program, there could be some random value there, and that can cause unexpected behavior, unexpected results in your program. Pointers are no different. They're a variable. When we declare a pointer, we get a memory address for that pointer to store its value. Its value just happens to be another memory address. So if we don't initialize that and 0 it out or null it out so that we control the value that's there, and then we try to use that pointer before we've appropriately assigned it a value, it can cause unexpected results in our program. So that's why we want to set it equal to 0 or null. It's essentially the same thing. So let's look at some examples of that. I'm going to comment that out just because we don't necessarily need it, and we'll move on to this next little chunk of code. Okay, so let's say that we defined a second pointer. Okay, here's the type, asterisk operator, and then whatever the variable name of the pointer is. At this point, I set it equal to null. Okay, I should do the same thing here. Set it equal to null. Null is a symbolic constant. We talked about symbolic constants in the last lecture. It just represents, it's a shortcut for a different value. And I forget offhand if it actually is a shortcut or a constant, symbolic constant for 0. Point is, you can use null or you can use 0. It doesn't matter. I like to use null because to me that's very clear that null means nothing, and I'm assigning the value of that pointer to nothing. All right, so first pointer, second pointer, I'm doing the same thing. Next, we're going to print off the value of the pointer. Okay, keep in mind that we don't need the address operator here. We're printing off the value of a pointer, and the value of a pointer is a memory address. So when we're printing off the value, we use %p. We use the format specifier to print that memory address, but the value of the pointer is the memory address. So we'll see here in just a second. I'm going to make sure I save it this time, and we'll jump over to the terminal. Get my fingers on the right keys here. All right, the value is nil. Okay, so that's typically what you see when you try to print off the memory address of a pointer, or the value of a pointer, excuse me, that's been zeroed out. Okay. If we go back here, we change this to 0. We'll save it, we'll recompile it, we'll run it, and we have the same exact result. Okay. So again, it's up to you. The important thing is that once you declare a pointer, you do something in order to take control and make sure that you do not get unexpected behavior inside of your program. All right, so we'll talk about our first operator. That is the address operator. At this point, you probably have a pretty good idea what it does. It's a unary operator who turns the address, the memory location of its operand. Okay, if we look at these 3 lines of code, you'll see we declare y as an integer variable, and we assign it a value of 5. That's depicted here using these blue boxes as memory addresses. We declare a pointer, okay, called y pointer. It's going to point to an integer value. Okay, we declare that here. Y pointer is still a variable. It still gets its own memory location to store its value. Now, we assign the value of y pointer equal to the memory address of y. Right? If the value of a pointer is a memory address, then because the value of y is a direct value, we have to use the address operator in order to provide a memory address. Right? So once all 3 lines of code here are executed, we get the following situation. We have y pointer. The value of y pointer is the memory address of y, so it now indirectly can reference the value of y. Let's take a look at that in code. All right, so here we have first pointer. Let me comment some of this out just so we don't have too much clutter here. And in fact, I'm going to move this down. We'll get this all in the same location. Okay. So here we have integer 1, here's our first pointer, and now we're assigning the value of the memory address of integer 1 to our first pointer. Okay, because we're doing this assignment operation right after we declare it, it probably makes just as much sense to combine that into one line. That is, we do something like that. That way we're declaring it and we're initializing the value all at the same time. At this point in time, when this program runs, first pointer will have a value of the memory address of integer 1. So let's take a look at how does that look. Let's print off some values. Okay, got that one. And the memory address of integer 1, we'll print that off and we'll say the value of first pointer is. Okay, and we'll print off that value. Okay, we'll save the file. Oh, that's not what I wanted to do. Go to our terminal here. Clear the screen, go ahead and compile it and run it, and there we go. Now, this is the whole purpose of printing off memory addresses, and this gives us the opportunity, the ability to look at 2 values and compare them. Okay, so if I set the value of first pointer to the memory address of integer 1, we'll see that they're the exact same. BFDB-CD38, BFDB-CD38. If I run this program again, they're different, but they're still the same value. Okay, every time we run the program, memory is going to change. We're going to get a different address allocated to us or assigned to us. All right, and finally, just to show you, the memory address of first pointer is, and now we can use that address operator on first pointer because, again, first pointer is a variable. It's assigned a memory address to store its value. So these 2 are identical, and this one is different. All right. Now this slide is just trying to depict the same thing. We declare these 2 variables, y and y pointer. each one gets assigned its own memory address. Okay, so y has a location of 600,000, y pointer has a location of 500,000. If I want y pointer to be able to indirectly reference the value of y, that is the value 5, then y pointer has to have a value of 600,000, which is the memory address of y. Okay, the last thing then we need to talk about is the pointer operator. So when we talked about a little bit ago, using that asterisk character, we use it 2 different ways, depending on the context, is how it's actually used. The one is how we declare a pointer. The other then is how we dereference a pointer. Okay, it's great that we can point to a memory address, but if we can't use that pointer to directly access that value that it's indirectly referencing, then it doesn't really do us a whole lot of good. So we use the indirection operator. It's simply called dereferencing a pointer. Okay, when we dereference a pointer, it's a unary operator, and it returns the value that its operand points to. Okay, so just like the address operator, the value that the pointer points to. So let's look at an example. We're going to go full screen here to try to make things a little bit easier. And we're going to comment this guy out here, this here. All right, we'll look at this last little block of code then. So, how do we dereference? Well, this is all we do. Okay, when we use that asterisk character, so the indirection operator with a pointer, then we're going to treat this essentially as a variable of that type. So this right here is like using this variable directly. Okay, both of them point to the same location in memory, but when we dereference the pointer, we're no longer working with its value, which is a memory address, we're working with what it references. So since it's dereferenced and we want to print that value, we can use the format specifier %d. All right, same thing with this line of code. Once we dereference it, we have an integer value, so we can treat it just like an integer variable. So we can say first pointer dereferenced times first pointer dereferenced, okay? And that's going to give us, we're using %d as our format specifier, that's going to give us the output of 7 times 7. So we'll compile it and run it, and you'll see, here's the dereferenced value is 7, and here's the square of 7. So 7 times 7 is 49. All right, now the last thing I want to cover is an important one, and that is that when we dereference a pointer, we're pointing to that same location in memory. Okay, if you want to read ahead in the chapter, there's a section that's going to talk about the constant qualifier that essentially will set something, a pointer or a value, a variable as read-only. We're not worried about that at this point in time. So when we dereference a pointer, and we want to use that dereference pointer in the left-hand side of an assignment operation, then we change that value. Okay, so if we do this, and then I'm going to go back up here to the top and steal a little bit of code. Okay, so we don't really care about this stuff anymore. Well, let's leave that one in. We'll get rid of the square one. But what we're going to do is we dereference it and we assign a new value. Okay, when we dereference it, we're pointing to that place in memory that was assigned to this integer. So if we change its value, we change it. We change it for both places because they're both pointing to the same place. So after I change it using the pointer, if I print off the value of integer 1, you'll see that it has a value of 999. And there you go. There's our output. It's 999. Okay, so what I'm saying then is this is a lot like saying integer 1 equals 999. Okay, these two lines of code are essentially equivalent in this instance because first pointer points to the memory address that integer 1 was assigned. So when we dereference it and assign a new value, it's the same thing as just assigning a new value to integer 1. All right, so that's our introduction. With that, you'll have the slide deck available to go through. You'll obviously have the lecture. On top of that, you'll have the code that we just walked through. Okay, so you'll have every bit of that code to work through. We'll have the practice lab. So there's a practice lab for pointers, and if you take a look at that, there's just 3 tasks that I have in there. They're out of the book. Okay, so if you want to go through that and find something else, you're more than welcome to do that. But here they are. The goal of the practice lab, the code I'm providing, and then there's one other practice that I'm going to give you, is just simply for you to work on pointers. None of this is graded, so you can work on them, and you can ask me for feedback. So if you're having trouble with something, we can work together before you have to submit a lab and get graded for it. Okay, so that's the whole purpose of these, because we don't get to spend it, we don't have that face-to-face interaction. It's a lot more difficult. You probably feel like you're a little more on your own. This is in lieu of that. This is to help bridge that gap. Additionally, okay, I'm going to provide you with this file, and this is in the, I think it's in the practice lab section. If not, it's in the sample code section. It's sample code section, pointers intro-practice.c. Okay, and this is practice, and it's a solution all in one. So if you don't, here are the tasks I've identified, and this is essentially the solution. You can see I've commented it out by the task. So if you don't want to see the solution yet, make sure you make a copy of this, or however you do it, and delete this section, and then work on these tasks one at a time. And then additionally, if you wanted to, you could do it again, but use a different data type. So what do I mean by that? Well, instead of using ints, use float, or use char, or mix and match. Okay. Again, up to you. This is for practice. This is just for your ability. It's something that we can both work on. It'll be a little bit easier to communicate on. So, providing the next lecture here shortly, and with that, we'll be talking about using pointers as arguments to a function.